All right, let's dive into one of the deepest mysteries in all of science. Seriously, it's a question that sits right at the heart of what our minds are and what reality itself is.
I mean, really think about this for a second. Mathematics? It's just a thing we made up, right? It's all abstract logic and patterns. And then there's physics, the study of the real, messy, physical world. There is absolutely no reason those two things should be connected. And yet, math doesn't just describe the universe. It predicts it with a kind of accuracy that's, well, it's almost spooky. So what on earth is going on?
And hey, we're not the first to be baffled by this. This puzzle was probably most famously laid out by the Nobel Prize-winning physicist Eugene Wigner. Back in 1960, he coined this phrase, the unreasonable effectiveness of mathematics. And man, do those words just perfectly capture the sense of awe that scientists feel when they really grapple with this. Okay, so let's really dig into the problem. Wigner didn't use a word like miracle lightly. He used it for a very specific reason. It's not just that math is a useful tool. No, it's way, way weirder than that. It's that math seems to know the secrets of the universe long before we ever do.
And this is the core of the mystery. You've got mathematicians over here creating these beautiful, intricate systems out of pure logic, totally separate from any real-world experiments. And then you have physicists who are getting their hands dirty, studying actual stuff. So why is it that the abstract games mathematicians are playing for fun turn out to be the unshakable rulebook for all of reality?
The best evidence for just how strange this is comes from what you could call math that waited. We're talking about mathematical ideas that were invented for purely theoretical reasons, sometimes centuries before physicists had any idea what to do with them. Let's look at some examples, because this is where it gets really wild. Okay, first up, let's go way back to the 1500s. Mathematicians were trying to solve some tricky equations, and they came up with this clever little hack, the so-called imaginary number, the square root of -1. For hundreds of years, that's all it was, a weird but useful trick on paper, a mathematical curiosity that had no place in the real world.
But then, fast forward 400 years to the dawn of quantum mechanics. As physicists started peering into the bizarre world of subatomic particles, they found something absolutely incredible. That 400-year-old mathematical trick? It wasn't a trick at all. It was the essential, non-negotiable language they needed to describe the very fabric of quantum reality.
All right, Exhibit B, the 1850s. For thousands of years, everyone just took for granted that space was flat, like the Greek mathematician Euclid described it. But then this guy, Bernhard Riemann, came along, and basically as a thought experiment, he developed a whole new geometry for curved spaces. He had no reason to believe reality was actually like that. He was just playing with ideas. So what happens? Just 60 years later, some guy named Albert Einstein is trying to figure out his new theory of gravity, and he's stuck. And he finds Riemann's purely abstract geometry just sitting on a shelf waiting for him. And it wasn't just helpful. It was the exact mathematical key he needed to unlock general relativity and describe gravity as the curvature of spacetime. The math was already there. And listen, this pattern is everywhere. It's not a fluke. The ancient Greeks messing around with conic sections, 1800 years later, Kepler realizes that's how planets move. Group theory, invented to understand equations, a century later, it's the foundation of modern particle physics. Again and again, pure math just seems to get to the truth first, sometimes by thousands of years.
So how in the world do you explain this? How do we solve the miracle? Well, there are two main schools of thought, two major attempts to make this unreasonable effectiveness feel a little more, well, reasonable.
On one side, you have physicist Max Tegmark's idea, the mathematical universe hypothesis. His argument is radical, okay? He says the universe doesn't have a mathematical structure. The universe is a mathematical structure. So for him, there's no miracle. It's just an identity. Physics is just what we call our limited human view of this giant mathematical object. Then on the other side, you've got a more philosophical take, sometimes called theistic realism. This idea suggests that the universe seems rational and mathematical because it was designed that way by a rational creator, or logos, and our minds can get it because we were designed with that ability. So for Tegmark, it's an identity. For the theist, it's a gift.
Now, I know what a lot of you are probably thinking. There's a third option that seems super obvious. Evolution, right? Surely our brains just evolved to be good at math. And yeah, that seems plausible at first, but this clue might actually be a giant red herring. And look, to be fair, evolution can definitely explain some basic math skills. We can all quickly guess if we're outnumbered or keep track of a few items. That kind of stuff was absolutely essential for surviving on the African savanna. No question. But here's the thing. Does needing to count how many lions are chasing you really explain our ability to understand things like infinite dimensional Hilbert spaces? The jump from counting berries to calculating the event horizon of a black hole it's just astronomical. There's simply no evolutionary advantage to being able to do that.
In fact, modern science suggests the exact opposite might be true. There's a cognitive scientist named Donald Hoffman who proved something mathematically called the fitness beats truth theorem, and it's shocking. It shows that natural selection consistently favors creatures whose senses are tuned for survival, for fitness, not for seeing reality as it actually is.
So what does that mean? It means evolution has actively hidden the true, underlying nature of reality from us. It's given us a simplified user interface. Think of it like the icons on your computer desktop. You click the icon to open a file, but you have no idea about the circuits and code running underneath. Our senses are just those icons. So our ability to do high-level physics and math isn't a product of evolution. It's us finding a way to hack past the user interface to see the raw code of the universe.
So, where does that leave us? Honestly, with no easy answers. But what it does leave us with is this profound, incredible sense of what you might call a cosmic resonance. This unbelievable harmony between the world inside our heads and the world outside.
And you know, Wigner himself said there are actually two miracles here. The first is just the fact that the universe follows elegant, beautiful, discoverable laws at all. But the second miracle, and maybe this one's even bigger, is that we exist and that our minds, somehow, have the ability to actually figure those laws out. And so we end right back where we started, with Wigner's incredibly humbling words. Whether you think this bizarre connection is an identity or a gift or something else we haven't even thought of yet, the unreasonable effectiveness of mathematics forces us to ask the biggest questions there are about the universe and our place in it. So I'll leave you with this. What do you think is the solution to this cosmic puzzle?